Hello everyone, this is Adnan and welcome to Chemistry with Adnan. And in this lesson, we will be covering the second part of topic 3.3, which is the mole and Avogadro constant. This is a pretty lengthy topic which contains lots of subtopics that we covered in our last lesson. So now this topic about the percentage purity, yield and stuff. This was the topic that was remaining. So let me just paste it on the whiteboard. The This is subtopic number 8 that we will be covering in this lesson. So let me just paste it here. Yep, here it is. And let me just adjust this. Okay, so it says that uh, calculate percentage yield, percentage composition by mass, and percentage purity given appropriate data. So we need to understand that what is percentage yield and what is percentage composition by mass and what is percentage purity and how to calculate them. So now let us take a look at percentage yield first. So yield. So what is yield? Yield is when you react something and you get the amount of product that you get, that is called yield, right? So uh, it has three types. We have theoretical yield, and we have actual yield, and we have percentage yield. Okay, so now what is the difference between these three types of yields? The first one, it is on paper. We don't actually perform experiment. We just use a balanced chemical equation to see that what will be the amount of product that will be produced. So for example, this balanced chemical equation it is telling us that if we react 1 mole of nitrogen with 3 moles of hydrogen gas, 2 moles of ammonia will be produced, right? So this is uh, theoretical yield. We did not perform this experiment. We are just looking at this balanced chemical equation. So if mole ratio is 1 to 3, then the yield of ammonia is 2. So let's say if I have 0.2 moles of nitrogen reacting with excess hydrogen, so then what will be the theoretical yield of ammonia? So now since mole ratio is 1:2 between nitrogen and ammonia, so we nitrogen is 0.2, so ammonia will be 0.4, right? You cross multiply, so 1:2 and 0.2 ratio, and this is x. 0.2 times 2, we get 0.4, right? So this is how we get. So this is theoretical yield. So remember, if they change the moles or mass, so then you will have to calculate the theoretical yield accordingly. Just like if we use 0.2 moles of nitrogen instead of 1, then the yield will not be theoretical yield will not be 2 moles, it will be 0.4 moles. Remember that. So this is theoretical yield. But when we actually perform this experiment in the lab, and what we get in reality, that is called actual yield. So actual yield is, it is always experimental. And the other thing that you need to understand about actual yield is that experimental actual yield will always be less than the theoretical yield. So why actual yield is always less than the theoretical yield? There can be many reasons. The reactants may not have reacted completely. The conditions may not be favorable. There may be a byproduct which we didn't take into consideration. There may be a loss of mass from changing, transporting it from one section to another, or one shelf to another. So there can be many reasons for the loss, but remember that actual yield will always be less than the theoretical. What is on paper, what is predicted on paper, you will always get less than that. Remember that. So now, as we have talked about theoretical yield. We have talked about actual yield, that it is always experimental. Now let's talk about percentage yield. So percentage yield, it is basically a ratio between the actual and theoretical. So actual yield, the formula is actual actual yield divided by the theoretical yield, and times 100, right? So this is the formula that we use. So now I have a question here. Let us solve this question. Magnesium reacts with hydrochloric acid. This is the balanced chemical equation that is given. A student reacts 4.8 grams of magnesium with excess hydrochloric acid, and the actual mass of magnesium chloride obtained is 17.1 grams. Calculate the percentage yield of magnesium chloride. Okay, so here now you can see that they have changed the mass or the number of moles of magnesium. So 1 mole will not be the yield of theoretical yield of magnesium chloride. So this 17.1, which is given in the question, this is actual yield, because there is no way we can guess actual yield. It must be given in the question because it is experimental. So this is actual yield. And now let us calculate the theoretical yield. So but the balanced chemical equation is magnesium plus 2 HCl. This is producing MgCl2 plus H2. So this will be this is 1 mole, and this is 1 mole. So the ratio is 1:1. Now I convert 4.8 grams of magnesium into moles, right? And when I do that, so how do I do that? Mass divided by the molar mass. So molar mass of or atomic mass of magnesium is 24. So 4.8 divided by 24, we get I get 0.2 mole, right? So if magnesium is 0.2, so magnesium chloride will also be 0.2 mole, because the mole ratio is 1:1 between magnesium and magnesium chloride. Now I need to convert it into mass of magnesium chloride. So now here, the formula that I'll be using is mass equals to number of moles times the molar mass, right? We have studied these formulas in our previous lesson. If you don't understand how to calculate mass when moles are given, you should watch the previous lesson, the first part of this lesson. Okay, so more magnesium is 24, and we have 2 chlorine atoms. So 1 chlorine atom weighs 35.5, so this is going to be times 2. So 71 times 24, uh, 71 plus 24, we get 95 grams, right? So 95 grams is the MR of MgCl2. Now we will multiply 0.2 with the MR of magnesium chloride, right? So 95 times 0.2, we get 19, right? So 19 grams. So you can see that theoretical yield is 19 grams, and actual 17.1. As I explained, that it will always be less than the theoretical yield, right? Okay, so now we have our values, which we can now put in the equation. So the equation is percentage yield equals to actual divided by theoretical times 100. So actual is 19 divided by theoretical is 17.1, and it times 100. So I would suggest that you should do it separately. First you do 19 divided by 17.1, because sometimes students who are not familiar with uh, you know uh, the oh, wait, I made a mistake. It's actually is 17.1. 17.1 divided by, and theoretical is 19, right? Yeah, so you should do this separately. if you try to solve this expression as a whole using your calculator. So sometimes, there's a chance that your calculator might mess up your answer. So 17.1 divided by 19, we get 0.9. So 0.9 times 100, you get 90%, right? So this is how you should do it in 2 steps. And this is our percentage yield. Okay, so I hope this topic is clear. And now we move on to the next topic, percentage composition by mass. So in order to understand percentage composition by mass, we can solve this. Let me just give you the formula first. The formula is mass of the element in a compound. So percentage by mass equals to mass of that element in compound divided by the relative formula mass of a compound, a relative MR, or formula mass of the compound times 100. Okay, so let me just write this as topic 2, percentage by mass, percentage composition by mass. Okay, so now the question says that, calculate the percentage composition by mass of hydrogen and oxygen in H2O. So we have a molecule H2O, and what is the percentage composition by mass of oxygen in this compound, and what is called the percentage composition by mass of hydrogen in this compound. So we can start from we can start from the first one, which is we can start from the first one, which is oxygen. So oxygen, the relative atomic mass is 16. So 16 divided by, and what is the MR of water? So hydrogen is 1. We have 2 atoms of hydrogen, so 1 times 2, we get 2, plus 16, so we get 18, right? So 16 divided by 18 times 100. This is for oxygen. Percentage by mass of oxygen, so this is 16 divided by 18, we get 0.88 times 100, so this gives us 88%. Oxygen by mass of oxygen, by mass oxygen is present in water. And now, the remaining part, it will be like, since there are only 2 atoms involved, 2 elements involved, so the rest will be hydrogen, right? So you can minus, like 88 from 100. So 100 minus 88, we get 12%. So, but let us solve it the right way. So hydrogen, so it's 2 divided by 18, and the total mass. Why am I writing 2? We have 2 hydrogen atoms, so the atomic mass of hydrogen is 1. So 1 times 2, this is the total mass, right? So mass of the element and compound. So hydrogen is 2 grams. So 2 divided by 18, and we get 11, right? So 0.11. So this will be, times 100, and we get 11.1, percent, right? So this is how basically you calculate the percentage by mass. So this is by mass hydrogen. So why don't you solve the let me give you a question. So KMNO4, so what will be the percent composition, percent by mass of oxygen in this in KMNO4, right? So remember, K is a different element, potassium, M is manganese, and O is oxygen. So solve this and leave the answers in the comments below. Okay, so now we move on to the third and the last topic, of this subtopic, which is percentage purity. So now let us see how what is percentage purity. Percentage purity, and how do we calculate it? So it also has a formula, and the formula is percentage purity. Percentage purity, it is equals to a mass of pure substance, mass of pure substance divided by mass of impure sample, mass of impure sample times 100, right? So let us solve a question on this. Let me quickly paste a question on this, and okay, here it is. A sample of impure calcium carbonate has a mass of 20 grams, and it contains 16 grams of pure calcium carbonate. Calculate percentage purity, right? So the formula is given, and a mass of pure sample. So a sample of impure calcium carbonate has, yeah. So this is pure, right? So mass of pure substance 16, and divided by the mass of impure sample, which is 20, and times 100, and it will give you the answer. So it is pretty simple. You just need to remember the formula that how to calculate percentage purity. So 16 divided by 20, this is 0.8 times 100, so this is 80% pure, right? So percentage purity of this sample is 20, yeah, like 80%. So this is how you calculate percentage purity. So I hope this is clear. If you have any questions, leave them in the comments. And if you need one-on-one tutoring session, by the Google form is given in the description. You can fill it out, and I will contact you. I also run a very successful community, high school chemistry, or with the name of high school chemistry on school.com, and I offer group lessons, for like 4 times in a month, once a week. You can join my premium package there, and it is free to join. Once a month, we conduct a free lesson, and you can ask questions, you can interact with other students. So it is a very good place to be if you are like excited about learning chemistry. So this will be all for today. I hope I'll see you in the next one. Take care. Goodbye.